concept of equilibrium of rigid bodies is derived from the Newton's first law of motion, which states that if the resultant force acting on a particle is zero, the particle will remain at rest, provided that it is originally at rest, or it will move with a constant speed in a straight line, provided that it's originally in motion. Therefore, a body is considered in equilibrium when its conditions, that is of motion or of rest, is unaffected by the forces acting on it. So basically, in case of engineering mechanics, there are two basic and necessary conditions in order to have an equilibrium. What are those? First being, for any system of forces, keeping a body in equilibrium, the algebraic sum of forces in any direction should be zero, or we can say summation of F is equal to 0. Another one is, for any system of forces, keeping a body in equilibrium, the algebraic sum of moments of all the forces about any point in their plane is equals to 0 and is supposed to be 0. That means summation of m is equal to 0. And these two equations, summation f and summation m is equal to 0, are the fundamental equation of statics, which are essentially used in determining the unknown forces and reactions acting on a body under equilibrium. And in this reference, a particular problem is called a statically determinate problem if the number of unknown reactions is equals to the number of equation of the equilibrium. And a problem is known as statically indeterminate if the number of unknown reactions is less than the number of equations in the equilibrium. And this kind of problems, statically indeterminate problems, you can easily see in strength of material. This kind of problems are more prominent in SOM or MOS,